intro. Okay. This is Martin and Alex from Question Defense. They do a lot of stuff with password cracking, and they actually were on the team Hashcat that won the recent DEF CON hash cracking challenge. So they are very well qualified to speak on this. Also, Martin goes by the name Pure Hate Online, and is one of the Backtrack 4 on the Backtrack 4 development team. And Alex, well, Alex is just our buddy.
That's right.
He's your buddy.
All right. So, since Adrian did such a good job of intro to password cracking and kinds of hashes and that kind of thing, obviously I'm having a lot of technical difficulties here. But so what we're going to talk about is this new tool called Hashcat, and this is basically just who am I, developed for Backtrack. I have a little IT store over in Louisville called Computer Rehab, and me and Alex, like Adrian said, have a website called Question Defense. It's got two parts. One part, we blog about technical articles, anything from really simple to really complicated. We don't care if there's a question, we'll answer it. And I'm also obviously a security enthusiast. And Alex, technology consultant.
Yeah, sweet.
I wanted to put classified, but he wouldn't let me. Anyway, so this is my disclaimer. We do not crack passwords for a living. We don't claim to be experts. We did not also write Hashcat. The thing about Hashcat is the guy that wrote it is German, and he doesn't speak English very well. He's gotten to be a really good friend of ours, and his tool wasn't really well known. We discovered it, and we've been really promoting it because we think it takes password cracking to the next level, which hopefully if the network holds up, we're going to attempt to show you that. And Adrian was talking about the documentation earlier for Hashcat. That's actually going to change. Alex is helping Adam rewrite all the documentation for Hashcat in English so that it will be easier to understand. It's not that Adam doesn't want to, it's just that he's not the best English speaker.
And probably doesn't care.
Probably doesn't care either. So we have been known to be wrong, and we're just a couple of geeks that are happening to get excited about cracking password hashes.
So, Question Defense. You only described one part, articles.
Oh, I'm sorry. There's a second part of Question Defense, which is tools.questiondefense.com, which is our series of online hash cracking tools that we've put up. They're not free. They do cost a little bit of money. The reason they cost money is because we have thousands and thousands and thousands of dollars invested in hardware and hosting and electricity and all that kind of stuff. Right now, I think I have a slide about it later, but right now we support WPA captures, NTLM, MD5, MD4, SHA1, and also RAR protected password files. Basically, you upload it, you make a little payment, you get an email a little while later with the results. It's actually it's undergoing an entire overhaul right now, switching from NVIDIA's CUDA architecture to the OpenCL architecture. But it won't be down, but just so you know that. So, a little bit about passwords. The reason they're so important is still to this date, passwords are the primary method of user authentication on the network. And as a result of that, it's also the weakest link in the network because as anybody that works in IT knows, you can put all the defenses and firewalls and anything into place, but if you let your users choose their own passwords, you're going to get owned. And another reason that cracking passwords is, I made this presentation in one day, by the way, so if anybody has any critiques later, it could be better, but I'm going to do the best I can. But so another reason is the admin passwords. Anybody that's ever worked on pen testing a network will know that generally the administrator will use the exact same password across the entire network. So if you can get one administrator password, generally you own every single box. And back in the Metasploit class, me and Relic actually showed how that works. Metasploit actually has a module, the SMB module, where when you capture the hash of one password, it's actually only a Metasploit Express, which is the paid version, but once you capture the SMB challenge, you can put that back in Metasploit, and you can basically auto attack the entire network, and it will log you into every single box that has that same SMB authentication. And Dave one time was playing around at his work with that, and he actually had 600 shells at one time on his computer. So, and that's at a Fortune 1000 company. So you can just imagine how many companies actually.
They like denial of services on box.
When you're in management, you can do that. All right, so we'll talk about what's new in password cracking. Adrian demoed some tools for password cracking. I'm not so much focused on the browser and that kind of stuff. Basically, what we're going to focus on today is hashes, MD5 primarily, but you can, as long as Hashcat supports the algorithm, you can input whatever hash you want. I basically just use MD5s for the demos because they're the most common. Almost every single forum still uses MD5 encryption, and lists of MD5s to crack are easy to get. So some of the new stuff in password cracking is as I'm sure some people are aware, is GPU-based password cracking, which is utilizing the GPU cores to crack passwords. The reason that works is because password cracking, the more threads it has, the more it can do. So if you have one core, you can have one thread. If you have 4 cores, you can have 4 threads. If you have SSE2 code, you can have 8 threads. If you have, for example, a NVIDIA 295 GTX, which has 160 cores, you can have 160 threads going on. So you can kind of do the math there, and we're going to attempt to show that off in a minute. Something else that's new with Hashcat is there's a much more complex rule set which you are able to make. If anyone's familiar with the rules in John, basically what you can do is you can create a rule that says, you can basically create a rule to do anything to the word. So in the most simplistic of the rule, you would say, take every word, capitalize the first letter, and append, a date to the end of it. For example, that would be a rule. And so you would run that rule with your password list against a list of hashes, and hopefully you would come up with some more passwords, since a lot of people do their name and the date, or their name and the date they were born, or something like that. And so what goes along with that, which I'm also going to try to show later live, hopefully, is the pattern detection software that Adam from Hashcat wrote, which basically takes the same concept of John rules, but it fine-tunes it, and it actually parses an existing word list for the words, and then creates patterns based on what Adam has seen in years and years and years of password cracking. So basically, every time they crack a list of passwords, they parse it for patterns, and then they keep those patterns, and then eventually he had enough patterns that he was able to code this dictionary expander to show off the patterns. And also, most new password crackers, John recently got SSE2 code, so it's a little bit faster than it was, but for the most part, password crackers on the CPUs don't use SSE2. I'm pretty sure that Inside Pros does, Hashcat obviously does, John does now. I'm not aware of too many others, but I'm sure there's some, and like I said, I've been known to be wrong. But I have a graph I'll show you in just a minute where even against password crackers with SSE2 code, Hashcat is significantly faster just on the CPU. Distributing cracking is new. I'm not going to go into that, but basically what that means is harnessing a whole bunch of CPUs together to do the work. I used to be into that, but ever since GPU cracking came around, I can basically do the same thing on one box with my 4 GPU cards as a distributed cracker with about 400 CPUs could do, modern day CPUs. Also new, I just threw that in there, there's a lot of new online hash lookup websites springing up all over the place with the space, terabytes and terabytes of space are getting cheaper and cheaper, and so people are putting up those kind of websites all over the place. So it's fairly easy to take a hash and look it up on a couple of different sites before you even attempt to crack it and waste your CPU cycles. All right, so What this all means is that patterns that were once, or passwords that were once considered secure are no longer secure. Passwords that are hashed without being salted are almost a joke, like NTLM. And anything under 12 characters is fairly easily broken. So this is what I consider the old school attack. Kane is not bad software. It does a lot of cool stuff. However, for attacking the hash itself, it's fairly archaic. It does a brute force, but as you can see from my slide, just note this, it does about 6 million passwords per second. So, and that's on Core 2 processor, where I took that, a modern day Core 2 processor. And another old school is John the Ripper. John the Ripper even has a jumbo patch to add the SSE2 code, and or maybe it's in there by default, I'm not sure, but the jumbo patch adds about 40 different other algorithms which John can crack. It's still a great tool. I don't specifically personally use it for password cracking. I do use the mangling feature and the rules feature sometimes to create word lists, but I use those word lists with other software. But so nothing against John. And so once again, although John the Ripper and Kane are good password crackers, they don't have a lot of the features that Hashcat does. The combination attack, the hybrid attack, and the speed characteristics of Hashcat. And oclHashcat is the GPU-based version. So there's Hashcat and oclHashcat, and they both, I'll get into the features in a minute. All right, so if you want to get the tools that I'm using in this demo, the first one's Hashcat, which there's a Windows binary and a Linux binary in both of these. There's actually a Hashcat GUI, which only works on Windows, and that's what I'll show for Windows. oclHashcat.
Oh, I didn't put oclHashcat on it, but that zip file I gave to everybody does have Hashcat in it. You have to unzip the raw file, so if you have 7-zip, you should have no problem doing that, but go ahead.
All right, and then so oclHashcat, which obviously you have to have OpenCL. Just real quick, all OpenCL is the implementation to kind of unify NVIDIA and ATI GPU drivers. It used to be CUDA and Stream, and everybody wanted something that worked cross-platform, and so OpenCL was born. And OpenCL should work with either the newest Stream drivers or the newest CUDA drivers. It's built into both of those. And then at the bottom is the kind of the new stuff that Adam wrote. He actually just put this out. It's the Hashcat utilities. This is where the dictionary expander that I'll show will be. All right, since we only have an hour, it's going to be impossible to show all the features of Hashcat and oclHashcat, but I'm going to try to show a few of the highlights. And if anybody has any questions after, they can definitely ask me or ask Alex. And also, Hashcat has a forum, and they also have an IRC channel on the Ryzen network. All right, so the main features of Hashcat, obviously, are it's free, it's multi-threaded, so that means that it takes advantage of your entire CPU. It's multi-hash. You can load thousands upon thousands of hashes in there. I think during the competition at DEF CON, we were loading 4,000 and 5,000 hashes at a time, no problem. Runs on Linux and Windows. It's definitely the fastest CPU-based multi-hash cracker. It's SSE2 accelerated. Almost all the rules are compatible with John and Passwords Pro. Passwords Pro is the software that's put out by that site Adrian went to earlier called Inside Pro with the hash generator. It's actually really good software too, but it does cost $100 or $200 or something dollars, and it's only Windows based. But just to not say that their software sucks, they were the second place team at the DEF CON password cracking contest. So it is good software. It's possible to resume or limit the session. It automatically recognizes recovered hashes. It can automatically generate random rules. So if you don't know how to write your own rules, you can generate random rules. It can work distributed. You can specify multiple word lists. This is a really cool feature. To this date, most password crackers, you either had to do one list at a time, or you had to combine all the words into one list or something. And Hashcat easily allows you to specify either a directory of lists or a couple of lists, and in the GUI interface, it's really nice, just little checkboxes for what list you want. And the number of threads can be configured. So if you want to password crack in the background and you only want to use one of your cores, you can do that. And the threads run on the lowest priority of the computer. So I'm not going to go over all these, but obviously Hashcat supports a ton of algorithms. So these are all the different types of passwords that Hashcat can crack.
Which equates to thousands of applications. So, PHP, VB, all sorts of stuff.
Now I put up SHA-256 and SHA-512. What is one of those equivalent to SHA-512?
Yes, and I'm not sure. It has to do with the encoding. So
If I see a $6 in a Unix password hash, which one would I use?
that is the SHA-1 pass-sol.
Okay.
And so Hashcat supports Linux hashes, but oclHashcat does not yet. Yeah, just jump over. Anyway, so you got to have some statistics. Everybody loves statistics. So I don't know if anybody can see this, but just real quick, we compare this against the Password Pro software. As you can see, Passwords Pro is only single-threaded and it's not multi-threaded, so it compares with Hashcat running on one thread. And this is on a Windows 7 64-bit, in case anyone can't see, Core 2 Quad Q66. And so Hashcat running on 4 threads obviously is 4 times faster. So Passwords Pro does 7.27 million keys per second, and this is only on 2 hashes. And then Hashcat does 33.1 million keys per second, which is significantly faster. And then the real features of Hashcat shine once you jump over to 500,000 hashes. You can see that Passwords Pro drops all the way down to less than 1 million keys per second, while Hashcat only loses 3 million keys per second. So that's pretty significant. And I'm not going to go over all of these, but it's basically the same all across the board. It's compared against John the Ripper, and anyway. So the main attacks of Hashcat, like I said, I can't go over all of these, but I just want to touch on them basically. The main attacks that Hashcat can do is a straight word list. It can do combinations of words, and the way that works is, and it'll make more sense when you see it on paper, but the way that it works is Hashcat has what's called a left mask and a right mask, and so you can add a dictionary to the left mask and you can add another dictionary to the right mask, and it will try each one and combine them together, and you can append digits or anything you want to the end, or you can just do a dictionary on the left mask and digits or letters or whatever on the right mask, and I'll try to make that more sense later. But so then there's the toggle case attack. What that does is it toggles the case of every single word in your dictionary or every single word in the brute force. Permutation obviously does lead speak, that kind of stuff, and then there's the obviously brute force. Brute force on Hashcat isn't totally effective since it's CPU based, but as you'll see in a minute, brute force on oclHashcat is extremely effective.
Ask you a question. Is that permutation? Is that like saying hybrid in the other tools?
No. A hybrid attack basically means that you take a dictionary and you append digits or letters or whatever you want to the end of it. So permutation does character replace, like changes E's to 3's or all capitals to lowercase or anything like that. And basically it's whatever Adam coded in there. I haven't found anything that it doesn't do yet. I mean, it basically permutates every word into 50 or 60 different iterations. So you also have to be careful with some of these rules because they can get out of hand quickly. You know what I mean? If you have a couple million words in your dictionary and you amplify every word 50 times, it can start to take a long time. So that's where Hashcat really comes in. That was kind of the old way to do it, you know what I mean, was to let John run with rules and mangling and all that kind of stuff for days and days and days, and then came distributed, which made it a little bit faster. But what Hashcat tries to do is do a more targeted attack. All right, so I'm going to show. So Hashcat runs from the CLI, And so there's the binaries, just like any other CLI tool. But what I'm going to show just for Hashcat is the GUI, just since we don't have a lot of time. And actually, the best part about the GUI is that at the bottom of it, it actually gives you the command line command and gives you an option to copy and paste it, which I really like. See down here at the bottom where I already have anyway, so there's the command line that it offers. So, and they do that because it's a little bit complicated at first. It has a steep learning curve, and so using the GUI and then looking down here and seeing what the deal is, you can kind of get a gist for how to use it on the command line. So what I'm going to do here is I have a hash file. This is the RockU text list. It was a big list of leaked passwords from a bunch of places that came out a couple of months ago, and what I've done is I've just rehashed it for the purposes of this demonstration.
Does that come with the tool, or do you need to download it?
I'll give you the link to download it. I think it's in just a little while. I got some word listings.
Yeah, I'm pretty sure Ron has that.
Yeah, it's
also
on Skull Security's site. But I have the links for all of that at the end for all these word lists that I use. So, like I said, I don't want to do a brute force attack. So what I'm going to do is I'm going to try the... I forgot which one I'm supposed to do first. Sorry. Oh, the rules. All right, so I'm going to do a rules. So I would do like combination words. And then what it's going to do is it's going to ask me about rules. Obviously, the hash type is over here. It's MD5 just for the purposes of this. This rule right here, if you go into the rules folder, there's some rules that, these two that say dead one don't come with Hashcat, but they are available on the site. But these other rules are the rules that come with it by default. As you can see, there's a leet speak rule. This is the Passwords Pro rule, so basically they just took their rule from Password Pro and added it here. The Combinator rule, which combines words together. Anyway, it's similar to the way the rules work in John, so if you're familiar with that, you'll know how to do this. Or this is the option to generate random rules. As you can see, you can do 10, 1,000, 100,000, 1 million. Like I said, these rules can get really out of hand, so you know, either want to experiment with small rules first and see what happens, or unless you have this on a dedicated box where it can run for a long time. So let's see what happens. Give me crackers is the output. So you can see that it just added all the stuff, and then you can always hit enter for the status, and you can see that, and it will tell you how many it's recovered so far. We haven't recovered any yet, but there we've recovered 4 already. And as you can see, the speed just on my little laptop right here is 11.03 million words per second, which is pretty good for a laptop. We've already beat Kane on a desktop computer, which is where I took that screenshot. 6. And obviously, I mean, like, I've only let this run 5 seconds. I already have 6 passwords. But obviously, if I let this run all day, I would probably be able to get most of the passwords. There's 11. See, I mean, I'm getting a few passwords every second. And
how many hashes are in your file?
65,000 or 650,000 hashes in the file.
now, where is it outputting them to?
I specified an output file, which is right here, crack2.txt.
If you don't specify one, it just puts it right out to the console,
It prints
right?
it to the screen, correct, if you don't specify one.
Yeah, there's actually a bug in Hashcat GUI with Windows 7 right now. This other kid developed the GUI, and that monitor, you can usually monitor the out file so you can see the hashes in real time as they come out, but it doesn't work right now.
So there's what I've cracked so far. So see, it puts it in a really nice file with hash and then password. Anyway, so you can see there's quite a few already.
You could just
Your
tail
source
that
file, is it like comma delimited space limited? Is it,
Sorry,
your source file is just like comma delimited file?
my source file for the passwords?
Right, yeah.
No, it's just hash, and that's it. Just
One
hash.
big.
And now if there's salts, you would have to put
You mean
hash
the
salt.
dictionary list itself?
Well, no, just whatever you're
Or the
tracking
hashes.
right now.
It's
Like
one
if I
hash
just go in
per
and
line.
grab a field out of a database that has hashes in it, How would I list it?
You would want to break it down to where it's just the password hash, for instance.
Okay.
You see what I'm saying? So it doesn't have the username and the home directory, whatever it may be, just hash.
Okay.
One per line.
Or hash
One per
solid.
line.
Yeah,
solid.
one per
Yeah,
line.
okay, right, one per
I'll just
line.
look for that.
Yeah, so like, I'll just show you like my file I'm using right here, just so everyone
So
can
it's
see.
simple things that defeat.
There's all I've input into it, the straight MD5 hashes.
Okay, cool.
Okay. All right, so I'm going to stop that attack, and then I'm just going to show one other one. And in reality, you could go through each of these one at a time and keep cracking on the exact same list, and it will actually. There's a setting to remove. I'm not sure where it is exactly, but there's a setting to remove the hash from the hash file after it's been cracked to keep them in order. So you would say remove, and then then your list of hashes would go down, and so the computational time to go over the list would decrease as you cracked more.
But does it know by default if it's already cracked the hash not to keep running the same thing on that hash again?
That's what I'm saying. It removes the hash from the file totally.
Oh,
So that it's no
what is that
longer
option
there.
set? That's
Well, in Linux, it's -- remove. I'm not a Windows guru. It's got to be around here somewhere. I'll have to get back to you on that.
Okay.
But on the Linux version, it's just -- remove on the command line.
But otherwise, it will try to crack the hash again and again, even once it did.
It's possible oclHashcat is the only one that does that. But I'm not. I have to get back to you on that.
Okay.
But I'm pretty sure that it works. I just don't know. So just to show one more attack, this is going to be similar. And so you can set the password length that you want it to permutate. The reason that you would do this is so that the length of the permutation doesn't get out of hand. You know what I mean? Because cracking 6, 7, and 8 character passwords is a lot easier than cracking 14 character passwords. So you don't want to waste all your time permutating out that high. But we'll set it at 8, which is good for. And once again, a lot of this depends on, are you just quickly trying to grab a few hashes, or do you have a big giant list you want to set to run a long time at home, that kind of thing. The guys there's another website called hashkiller.com, which is run by one of the Hashcat guys, and they compete. They every day they post the list of uncracked MD5s, and people download the list and try to crack as many as they can, and then upload them, and then basically on your form next to your name, it lists the number of hashes that you've cracked. It's just kind of a status symbol. But it's a lot of fun to practice cracking passwords because the theories are the same, it's just the hashes that are different. So if you get good at MD5s, you can create patterns that will crack NTLMs and so on and so forth.
So if you don't have a job or a life, you can get in the top 1,000 people on Hashkiller.
Right. Exactly.
So where are you guys on that list?
I've never cracked one personally.
I've honestly only got a few thousand because I have a job and a life. It's tough crowd. All right, so as you can see, what happened here was it added the hashes that have already been recovered, Adrian, to the memory so that it's not going to try to crack those hashes again.
Okay.
So, and you can just press enter for status. See how now I've recovered 2,839. I'm running at 13.59 million per second, which is obviously probably going to get faster. The reason that this slowed down was because of the permutation attack slows everything down because it's not doing straight words with something appended to the end. It's basically using a whole lot more memory. 5,039. 53,022. And this is not some password list that I set up. This is a leaked password list from a well-known database that I actually cut it down to 650,000. There's actually like a couple 100 million passwords in there. And so that it was recent enough that these are all real life common passwords. And
Change my Gmail account password, what you're saying? Or
maybe. If it's your name with the date on the end, I would.
no.
Anyway, so that's all I'm going to do on that. As you can see, 74,000. So I'm killing it. If I let this run all day, I would probably crack over half these hashes, which cracking half of 650,000 hashes is pretty good for my little Windows laptop. And so keep those numbers in mind. And Alex is going to show you some OCL Hashcat attacks. Oh, I have to wait, I got a few more slides. So that was the permutation demo attack. And I'll put these slides up so you all can have the commands. But like I said, if you can, on Hashcat, if you can use the GUI. Oh, whoops.
Shift F5.
There we go. All right, so like I said with Hashcat, if you can use the GUI, it's really nice how it gives you the command at the bottom, and then once you learn how to do it, you can do it from the command line. But the GUI is really nice. There's a picture of the GUI.
And it's supposed to work on a wine also, doesn't it?
I have not. I have been. It would be in Backtrack if it worked properly on wine. I have not got it to work properly, and it's only a file system problem.
Because when I saw it does something about do settings for supporting wine.
Yeah,
it doesn't really work.
Well, it does and it doesn't, and so
Okay.
I've been making a list of things that the guy that wrote it is not really part of the Hashcat team. He's kind of a friend, and so I got a list of stuff I want to submit to him because I would like it to work with wine perfectly. But anyone can feel free to try it on wine. Currently, it just doesn't work good enough for me to actually put it in Backtrack. But as soon as it does, I will, because the GUI is nice. It's easy to use. Anyway, so here's some more Hashcat speed tests, just to show you. As you can see, this is compared against Password Pro again. The reason they do that is because basically Passwords Pro was the best password cracking software on the market until Hashcat came around. As you can see, Passwords Pro on System 1, 7.27 million passwords per second, and Hashcat with only one thread on System 1 is 8.8. So even just the software compared one thread at a time, it's even a million keys per second faster. So I'm not going to go over all the stats again, but all right. So the next tool is OCL Hashcat, which basically is the exact same thing except it's GPU accelerated. It does work on Windows. It does not currently have a GUI, so you have to learn how to use it from the command line. Here's the features are, obviously it's free. The biggest feature which attracted me to this, I used to use another tool that was called the CUDA Multiforcer, which is a CUDA-based NTLM cracker. The problem with it is that it did not utilize multi-GPUs. It only used one GPU. So I have a box with a series of 295 GTXs in it. So the reason that was bad was even on one 295 GTX card, it's basically two cards inside. So I was really only using one half of one card. And so OCL Hashcat can utilize every half of every single card. So with 4 295 GTXs, it's basically like I have 8 GPU cards. Runs on Linux and Windows, uses OpenCL. It's definitely the fastest multi-hash MD5 cracker on NVIDIA and ATI cards. It supports wordless and also does brute force mask attacks. It can mix the wordless. We're going to show that in a minute. There's a setting. Normally on Linux, when you run a GPU-based cracker, it makes your desktop completely unusable. And so there's a flag in there where you can set what's called the nice level. So a nice of 1. Obviously, the cracker wouldn't run as fast, but you would still be able to work on your desktop. We don't run a desktop, so we're not worried about that. But some people do, so it's a nice feature to have. Anyway, supports huge numbers of hashes. Obviously, you can load 4 million hashes at once. And I've tried that. It works. And it includes the Hashcat's rule engine also. So you can use the same rules. The only bad part so far, and this is subject to change, is that it does not support as many algorithms as Hashcat. There's a variety of high-tech reasons which are way over my head, which Adam could explain of why some algorithms aren't supported. But Most of the main ones here are. The only one that I've needed that's not on here is Microsoft SQL passwords. That's the only one basically that I've run into that wasn't supported that I needed an oclHashcat. So here's some oclHashcat statistics. These are just compared against another popular GPU program. I don't even know how you say that, IG hash GPU or something, I don't know. But as you can see, once again, it shines in multiple hashes. With 2 hashes, the speed's similar, 200. So, and just this speed, remember what we were getting about 30 million with Hashcat? Now we're up to 23,000 or 2,392,000,000 keys per second. So we've considerably amplified our lookup process. And so as you can see, it's similar speeds with 2 hashes, but when we load 500,000 hashes, this one goes down to 832 million keys per second, but ours stays at 1,089,000,000. I don't know. Anyway, keys per second. So you can look at that later if you want to look at some more statistics. The main attacks of oclHashcat are brute force, or these are the attacks that we're going to show. Brute force, which obviously, hopefully everyone knows, brute force is just specifying a character length and trying every single thing in that character length. So lowercase a to z, uppercase a to z, 0 to 9, and all the special characters. And then there's the hybrid mask attacks. Like I said, Alex is going to show us how to do all those with the with whatever we specify appended to the end of a dictionary word. So you'll see, it'll make sense when we show it to you. And then the best attack of all, which is the fingerprint attack, and hopefully we can get that going. Real quick, the way the character sets work in oclHashcat. All right, you want to explain the character sets?
No, go ahead.
Okay. Anyway, so, and this will make more sense when it's on the command line, but the $L means lowercase, $U means uppercase, $D means digits, $S means special characters. And the way that you specify more is you do a -1 and then you do the character sets that you want. And you can also remove that and just specify the straight letters to make a custom mask. And so here's an example of a custom character set at the bottom. So you have to have a left mask and a right mask, which basically means you have to have characters on the left side and the right side. It's just the way Hashcat's coded. So if you were going for a 7-character password, you would have 4 characters sets on the left side and 3 character sets on the right side for a total of 7. And so here's an example of a custom character set. You give this flag, and then you give the D for digits. So what this would be is hexadecimal. So I'm giving D for digits, but then I'm only specifying the first 6 letters of the alphabet for a base 16 number set. So that would set the character set to hex. So that's how you do that custom character sets. So this is an example of a brute force. Hold on, real quick before and so just real quick, md5.txt is the list of hashes to be cracked. -M is the type of hash. -N is the nice setting I was talking about, workload tuning, 1 being the nicest and 160 being the heaviest. You can give the GPU devices flag. By default, it will use them all. But if you give the GPU devices flag and you only wanted to use one card, for example, because you were watching something on the other card, you could do that and only use one card and still utilize your other card for your desktop. And there's a GPU loops flag too, which just adds a little bit more. And so this is how these ones down here at the bottom is how you would show the left mask and the left mask and the right mask. And so just to show you up here in this command, see how I gave the -1. And so what I did was I defined -1 as lowercase, digits, special, and upper. And then so over here on the right, I have a left mask and a right mask where I defined 6 characters for a 6-character brute force. And so Alex is going to show us how to do that real quick. Cool. You all sit here?
Yeah. Again, my name's Alex. I'm fairly new to password cracking and information security in general. I have done a lot of information security over time, but not specifically in the information security scene. But I've worked in online gaming, telecommunications, and I currently work in healthcare. So anyhow, the beauty of Hashcat is it's really an application that helps people understand password cracking, because in the past, password cracking has specifically been about brute forcing, and not many people understand the in-depth pattern matching of password cracking, where people always, the typical character sets that you want to use are lowercase and digits, because most people use lowercase and digits. And so it's not to say that nobody uses uppercase or special characters, but it definitely doesn't happen as much as specifically lowercase and digits. So, if you have limited resources and you want to crack longer passwords, lowercase and digits are the best combination to use to try to get the most out of the resources that you have to crack the passwords. So Hashcat's philosophy on the left and right side is really cool, because you can take the same word list and actually put it on the left side and also the right side, and now you have words that you wouldn't have necessarily thought of in a dictionary, because it's combining every word on the left side to the right side. So you can also take a word list and just add, say, 4 digits to the right side, and so, or you could prepin those 4 digits and do 4 digits in the beginning of every word. Somebody might use their birth date or something like that. So something that's fairly new to password cracking is something Adam came up with. It's called a fingerprint attack, and it's for when you get large lists of passwords. And so a large list of passwords may be, say, like you were saying earlier, somebody may have hacked Google and gotten 100 million passwords or something like that. And so you're looking for patterns of words, and more specifically, even if you took a smaller company and they had 10,000 employees, everybody may use, say Humana in the front of their password if they worked at Humana, along with, their kid's name and some digits or something like that. And so you look for patterns, and with patterns you can create larger word lists, and you take those patterns and combine them with variables such as digits, lowercase, char sets, whatever it may be, and your percentage of cracking passwords is going to get higher and higher. And the more you do password cracking, you'll create dictionaries that are based on real-world lists that are going to give you a higher rate of cracking passwords. And so the more experience you have and the more lists you build on yourself, the higher rate of passwords you're going to crack. So with oclHashcat here, we are going to go in here. No.
Okay.
It's right here.
Oh, that's right.
So what I did earlier, this box is a little bit slower than the box that we normally use to crack passwords, and the other box is being used right now. So what I did earlier, which took about 15 minutes on this box, it takes a little bit less than a minute, I think, on our other box, but I brute forced, I basically took the NTLM password hashes out of the DEF CON password list, and I think it was like 30,000 or close to it, 31,000, something like that. And I was basically just taking Adam's password fingerprinting concept and applying it to these 30,000 hashes. And so I basically trimmed the list down to the NTLM only hashes, and I ran a 5-character brute force on the NTLM hashes. And so in the beginning of password fingerprinting, you use something like a brute force, for instance, to come up with the initial patterns. And the initial patterns I came up with are this was the initial list that it came up. So this is what Hashcat spit out, and you'll see stuff: Clark, bears, ducks, just simple stuff. And so then you cut that list down and create a dictionary file out of it. And this is where password fingerprinting comes in. So this is technically a dictionary file now that these are real passwords that I've gotten from that DEF CON list. Adam wrote this tool called the expander, and so what you do is, I think it's just in and out. Yeah, there it is. So what you do is you take the expander and take an input file, for instance, that dictionary I just created. Oops. which is the 5 char out, and the expander is really simple. All it does is it takes the 5 character combinations that you have and makes every possible combination out of those 5 character combinations. So if you had 1, 2, 3, 4, 5, it's going to create 1, 2, 3, 4 on each separate line. And so it's every single combination, and you'll see in this, see how it's just a lot of single digits, and it takes every possible combination out of those 5 characters that I cracked earlier. And so what you do with this is you would like sort -u to make it unique. And I think I meant to name that new file. Oh, newest file. So, and now we only have 1 of each combination, because you're going to come up with a lot of the same. So you can see now all the combinations that it's created. The idea behind password fingerprinting is now taking this word list and let's do name. It's taking this word list, which, what did I call that, newest file? And running it on each side. So you're trying to fingerprint what other people at that company, for instance, might use as their password file. And so I'm outputting that to, oops, what did I forget? Oh, it did. Oh, we're not going to be using the GPU on this box. But what I did this earlier, and I took these. The first one was I first created the NTLM 5 char dictionary from the brute force. I ran the expander on it, and I called it the expanded dictionary. This is all from the 30,000 NTLMs from the DEF CON contest. Then this R1 is when I ran it, the expanded dictionary on both sides using Hashcat, so on the left and the right side. And this is my R1 is the first run through of those NTLM hashes. So this is like one pattern we noticed they used a lot was DEF CON, for instance, and so they would capitalize certain letters, add digits in certain locations, stuff like that. And so we took, after you run through once, the whole idea of fingerprinting is you're constantly expanding your list of your dictionary list, basically. So it's going to constantly get longer and longer. And in the beginning, you may end up cracking 600 of the NTLM hashes to begin with. After you run the expander on it and run it through again through oclHashcat, you may end up with 650 hashes now or something like that. And you're going to constantly expand it, run more, expand it, run more. You also want to cut out of the loop. It's basically, Adam calls it the looping process, which is you run a dictionary attack against it, you take all the hashes out, you run the expander on it, then you run that new dictionary on it again and again, and you just keep expanding it. So your list continually gets bigger and bigger, and you're going to come up with newer and newer passwords. At certain points in the process, you want to cut out of it, take the dictionary that you've created, and maybe add 2 characters to the end of it, which could be lowercase, they could be digits, special characters, anything like that. And you're going to want to add those to the end because it's going to come up with newer combinations. You take the cracked hashes, the passwords out of there, run it through the expander again, and then continue the attack. So I'm just going to go back to this tool server here real quick. Because I can show a basic brute force, for instance, with oclHashcat. Do you have hashes in here? Oh, those NTLMs. So we'll just output them in real time.
Have you noticed a significant difference in the speed between like a 32-bit compiled and 64-bit compiled version of Hashcat?
I don't know specifically, Martin.
Just the memory addressing, it can hold more in memory, basically, so it can do more. Theoretically, all my machines are 64-bit, but I can tell you that on Backtrack, the Hashcat is just as fast as it is on my Windows laptop, and Backtrack's only 32-bit.
So this command right here is just a basic Hashcat command where we're telling Hashcat to crack the hashes that are in that NTLM file, that text file right there. We're telling it to use it 80 threads. Then we're telling it that we're setting a group of char sets with that -1. And the group of char sets is lowercase, digits, special characters, and uppercase. And then we're telling it to try to brute force 7 characters. So you can see how even in a brute force there's a left and a right side. So we've got 4 variables on the left side, and this means variables means characters. 3 variables on the right side. And so what it's going to do is try, for that 1 that it puts there, it's going to try every lowercase character, every digit, every special character on a US keyboard, and every uppercase character. And so when we do this, it takes a second to fire up all these GPUs. But once it does, you can see it's already cracking hashes in real time here. But so you can see right now on these NTLMs, oh, I didn't even specify NTLM and it's cracking those. Those must be MD5s in that NTLM file. That's why you never got it. So those are really MD5s. I should have also specified the type of hash here. I'm gonna quit that and see if we actually get any NTLM.
That was the practice list Minga gave me for the dev competition. He told me they were NTLM.
So with Hashcat, you actually have to specify a type of hash, right? And so typically you might get a password from, again, PHP-BB or something like that, and depending on version will depend on how it's hashed, how the password's hashed in the database. And so typically the default on Hashcat is MD5, and which is also -M0, 0, like that, which is just specifying MD5. Now NTLM is -M1000, and so we'll see if these are actually NTLMs. I think they're just going to all be MD5s. So the -M specifies NTLM, and you'll see, I bet they are just MD5s. That's hilarious. So this shows when it's first fired up, you'll see that we actually have 4 GeForce GTX 295s, and each of them has 2 GPUs in it. So it looks like 8 actual CPUs or GPUs in this case. And so we're cracking NTLMs at around 750 million per GPU, which is around 6 billion combinations a second. So this is fairly rare. There's not many of these around.
I bet it is an MD5 list.
I bet it is. So, but you can see, so we've got 7 character brute force we can do in just over 3 hours, and that's every single character set. So it's 96 times 96 times 96 times 96 times 96, 7 times, which is however many combinations that says down there. Trillion or something. Or quadrillion, something like that. Yeah, it's a tough.
I need some commas there.
So, but again, to go back to OCL Hashcat in general and password cracking in general, it's way more than just having the biggest machine and the most power. For instance, at Hashcat, the Password Pro team, I think, had 5 or 6 more members than we did on our team, and this also gives you an idea how good OCL Hashcat is. They also used OCL Hashcat even though they developed GPU password cracking software themselves. They know that OCL Hashcat's superior. So
they admitted in the end that they were using our tools too.
Yeah, and so anyway, OCL Hashcat is really phenomenal when it comes to password cracking, and it really deals with. When I first started using it, I was like, this is so complex that it's going to take too much to learn. I'd rather just throw something in and brute force it and be done with it. I mean, I'm not somebody who cracks passwords on a daily basis. So it's really great because it shows you that the pattern matching, the rule sets, the dictionaries you use, the real world scenarios, that's really where you're going to be able to crack the most passwords. And so flipping that, creating your own passwords or enforcing a password policy, you want to make sure that people aren't using real words or, just taking a word and adding numbers or leadifying it, as they say. You want to make sure that it's combinations that don't mean anything and don't relate to anything, or if they're using, something else, you want to make sure they use sentences or longer passwords. So
Sort of negate rainbow tables.
it does. I mean, they're still there. Don't get me wrong, but like one of our friends, another guy that hangs out in the Hashcat channel, just created a 7-character lowercase and digit rainbow table for MD5 hashes, for instance, and so you can literally look up any MD5 hash that's got a 7-character or less password in less than like 0.5 seconds. So he created 4 or 5 text lists and separated them by directory, and it's just, I think he said it was 600 gigs or something. It was something crazy, even for just 7 characters.
What's the longest?
The problem with rainbow tables is space. You know what I mean?
It's huge. Yeah.
And it's huge. Like we
Carry
have this.
drives around.
I mean, we're using like 20 or 30 gigs for those box tops. You know, versus 600 gigs for rainbow tables.
And that would only be the 7 characters. So the GPUs themselves, specific. This is another reason GPU password cracking is amazing. Is the GPUs are making it where it's happening so fast, rainbow tables are way less important. But for instance, like, so we're cracking 6 billion NTLMs. I think we cracked something like 19 billion per second MySQL passwords. But on the flip side of that, WPA, we only crack at 120,000 combinations a second. So there's certain technologies where, you know, rainbow tables could still make sense. WPA is obviously not one, but you know, and certain situations where they don't. Here in the near future, I would guess that things are going to get so fast if you don't have 14-character plus long passwords. I mean, somebody
do
can
15, 14.
Hashcat will do up to 14
because that's
right
until
now.
I'm zoned.
Now, I'm mostly just messed with domain cache credentials. If you're doing WPA with Hashcat, you have to use the SID as the salt in the end.
You're talking about if you.
We don't crack
DES.
WPA with Hashcat. Doesn't crack WPA.
No,
Oh,
WPA is different. You're talking about DES, and so it works. Anything that's salted works in the exact same way, except for you just put hash. You either have a salt file, like if all the hashes have a common salt, like in what was that we did? Oracle 10, for example, they had a common salt.
Is it really a salt if it's a common salt?
No, what he's saying is you might have one salt for 1,000 passwords in one scenario, but you may also have 1,000 passwords with 1,000 salts, and you don't even know how they match. So Hashcat will allow you to take all the hashes and put them in one file, and 1,000 different salts and put them in one file, and it will try every combination on every password, every hash, and every salt you see until you come up with a thing. It makes the number of combinations infinitely bigger. However, there's scenarios where that could happen. You know what I mean? It also, when you're talking about cracking salted hashes, you're talking about doing things in a much slower fashion than you are if it's just an MD5 hash, for instance, because it's got to, depending on, like, if you're cracking 1,000 hashes at a time, because it's all different. It can't apply the same salt to everyone, so it's got to try every combination on that hash every single time.
But it's still significantly faster because the same problem applies to CPU-based crackers. Anytime a salted hash is just by default more secure than a non-salted hash because it's more difficult to crack. Only in large quantities. Now, one here or one there isn't going to be that big of a difference. But when you're talking about thousands of passwords,
And it makes
from
pre-computation
big databases,
attacks like rainbow tables pretty damn impossible.
Yeah, that's exactly why you can't have
terabytes of
That's why you
data.
can't have WPA rainbow tables, because every
Actually, I've seen them, but the thing is that they're very limited because you have to
yeah, it's
throw
like
in.
Linksys.
Yeah, the
you
SID
know,
has to be
something
hashed.
like that.
It'll crack it if you use a common common WPA password, and your SID happens to be Linksys.
I mean,
Yeah,
just to give you an
exactly.
idea, we made some WPA tables in offensive security, and they contain 64 million words and one ESS ID, and the table for one ESS ID is 1.9 gigabytes. So that just gives you an idea of the size and the space. And for example, we crack, going to WPA, we crack WPA passwords. We can try 980 million words in less than 3 hours. So that makes rainbow tables for WPA are kind of a thing of the past. All that's going to be happening is this GPU stuff is going to get faster and faster and faster. Can you show the dictionary with the letters at the end? Just because I got it in my
Letters at the
slides.
end.
like just dictionary on the left mask, and then 4 numbers on the right mask.
Oh yeah, like do you
I change it
have
I bet those are MD5s. I change
You
it
don't
to
have a
MD5.
rock,
Do
yeah.
big lists.
Now, are most of the command line options the same in both versions of Hashcat?
They are OCL Hashcat is a little bit different than Hashcat, so the command line options are just a little bit different. The way that the character sets work in OCL Hashcat is kind of specific. So here's another attack. I just had a few different ones in my slides.
Yeah, so this is a combination attack where you're running Hashcat again on that NTLM list, which is really MD5s, and you're specifying 80 threads, and you're also specifying big.lst, which is a dictionary file here, and then you're saying take every combination in that dictionary file and add 4 digits to the end. So $D equals 1 digit. We'll see if we actually. How many are in that file? Oh, 17,000. So again, this box takes a little while to spin up the GPUs. There it goes. Yeah. My name. So this was this from? This is why he chose that. This is one of the rules they used was
Right.
words with digits.
With words with letters at the end. But see, so if you can, the reason that this is cool is see how there's a real pattern here, words with numbers at the end. So if you can recognize a pattern, so if you can take a list, what the fingerprint attack does is if you can take a list of 1 million passwords and you can crack 50 of them or 100 of them, you have enough to recognize a pattern. And then so based on that, you can use the expander, but you can also do rule-based attacks like this, where we're specifying every word in a dictionary with 4 letters at the end, because commonly people put the date, at the end of their password, the date they were born, the date their kid was born, or, 2 digits and 4 digits at the end of a password is always really good, and then a special character at the end. Most common Windows domain admins require you to have 1 capital letter, 1 digit, and 1 special character. So what are people going to do? They're going to capitalize the first letter of the word, of their name, for example, and then they're going to put the date that they were born, and then they're going to put a star or an asterisk or a $sign or some easy to remember special symbol. So if you can recognize a pattern like that, you can get this so specific that it will look for those type of passwords.
Also, if you're doing a corporation, I have to imagine, project names or name of corporation and a series of numbers.
Absolutely, and that's where something
on devices.
Something I didn't have time to show in this demo that I wanted to was there's an old tool in Backtrack that one of the original developers wrote that hardly anybody knows about. It's called wyd.pl. And what it does is if you just use wget on the command line and wget a whole website, and wyd, I don't know what it's called, but y.pl will actually parse even the JPEGs, the PHP files, everything, and it will create a word list out of the entire website. And so if you were doing a penetration test on a company, for example, and you had dumped their database and got 100 million hashes, the next step would be to download and parse every single website that they own or is linked to them or whatever, and you could build your dictionary from there, and then you could move on to some of these things that Alex showed us.
Robert Wood has a tool called, I think it's Cool or something like that, CEW, whatever.
Yeah,
that does a lot.
It does, and that's a very similar tool. It's kind of the newer version, and it does work good.
So here's another combination where I take the 1 and I'm specifying 4 different character sets or every key on the US keyboard and then applying it to the end. Also, I wanted to point out one misconception about Hashcat, and it took me a while to figure this out, is that when you specify, say, a word list and then 4 variables after, it's not going to try like every word in that list with 3 variables after it. So it's not incrementing. It is specifically doing 4 characters afterwards. So it's not going to try, if Alex was one of the words in the big list, it's not going to try Alex and 1 number, Alex and 2 numbers, Alex and 3 numbers. It's going to try Alex and 4 variables after always. So,
but that also makes this really easily scriptable in a batch script. And there is a batch script included. It's not the best. It needs some work, and we're all working on it, but it's really easy to just script all these attacks one after the other and let it go. And the output file will keep appending to itself. so it doesn't overwrite itself.
So in the batch script, you can specify many types of attacks and have it go through a bunch of different patterns, which you'll see right here. So right here it's saying run a brute force with lowercase as the first character, digits as the next 4 or 7 characters, basically. And so you can see through this shell script that we've been working on, it adds a lot of different types of attacks, basically. And the documentation's horrible on oclHashcat right now, and Hashcat for that matter. And so learning it, you'll either have to ask somebody, figure it out yourself, or look at this shell script. What's that?
Is it out there in German?
Yeah.
And the forums are pretty
Oh,
good.
his site is not.
No, his site is
no,
English.
it's English. There's just no documentation.
Yeah, the forum's about the best place to search
Very
on.
little. I've written a couple articles. What's that?
Yeah, the forum's about the best place to
Yeah,
search
the
for.
forums
Yeah,
has some
the
stuff.
forum.
I got this error, look for it. You know, that's,
we are going to come out with documentation here soon.
We
We're
wrote some
actively
articles on
working it.
question defense on it too, basic, and Alex is working on some documentation for it. But this shell script, once we get it working the way that we want it to, will be really effective. I mean, as you can see, it completes, and some of these attacks are completed really fast. It looks like a lot, but the shell script as it sits right now can finish, fairly quickly depending on the size of the dictionary. Some of the attacks are dictionary specific. You don't ever want to load a big giant dictionary, the biggest I've ever used probably is 500 megabytes, which is probably still too big. But even this batch script, the fingerprinting attack is way superior to the batch script.
Is there any questions anybody has on Hashcat, oclHashcat from the CLI or anything like that?
What was just go over the masking on the end there again, for the left and right? Like the question mark L.
Yeah, so
Meaning of all that, just
the L's meaning question mark L's meaning lowercase character set in this scenario. So when you say that line right above the last echo there, and it shows question mark L 4 times, then question mark L 4 times. What that's basically saying in Hashcat terms is try only lowercase characters for all 8 character places, and it's basically saying it operates in 2 sides, right? So you're specifying 4 on this side and 4 on this side, and what it's doing is doing every combination of lowercase in 8 character places. And so if I change those L's to D's, for instance, it would be digits. If I change it to S's, it would be special characters only. And so it goes back to pattern matching, and again, even further, it goes to fingerprinting. It's finding patterns that real people use. 1 uppercase character followed by 6 lowercase characters followed by 2 digits or something like that.
So if you did like question mark L or question mark D, it's only going to look for lowercase in the first.
Correct.
Exactly.
And that's why we specify the 1 in the beginning. So the targeted attacks, you can just use digit, letter, but if you want to use more than 1, that's where the 1 comes in. If you think about it like an array in programming, where you assign more than 1 variable to the array, so basically to the 1, we're assigning all those digits, and then so when we put the 1 in the attack, it knows to use whatever character sets we assign to it in the beginning.
Exactly, and under the same concept, you could probably, I've never actually done this, but I'm guessing you could make a -2 and have 3 character sets on the right side, or so, like lowercase digits and special characters or something like that.
And that's putting your password on the dictionary list with dog. It's appending in that last line 4 lowercase, then the word dog, then 4 lowercase after it.
No dictionary in this brute force attack at all. 0 dictionary, unless you specify the dictionary. That's what's cool about
When you
Hashcat.
specify the dictionary, it does
So instead of the
variable, the password, and then the variable.
no, it would do, again, think of it as 2 sides. So you could take your dictionary and put it on the left side, which would
That's the
cancel out the 4 L's.
Either or.
Yeah, exactly.
Right. You either append, so when you're working with a dictionary, you either append to the beginning or the end.
Got it.
So, and one of the other cool things is Hashcat, because dictionaries are such great attacks, Hashcat's really cool because it's the only app that I know that will take 2 dictionaries and combine them and try every combination of every word in the left dictionary with every combination of every word in the right dictionary. And that's why the expander works so well in the fingerprint, because you end up with capital D on the right side combined with every word in your dictionary list or something like that.
You mentioned US keyboard. Can you put like multiple keyboards in there?
You could do whatever you want.
You can do whatever character set you want.
Yeah.
So if your keyboard,
Like if I gotta know my password. You're using US keyboard in there.
you can do. There's a with the -1. You can also do a custom character set. So if your keyboard will type the letter.
Yeah, and
it will load it.
I haven't tested, a bunch of different char sets themselves from different languages, but I'm pretty sure as long as your shell will handle it, that Hashcat would handle it, no problem.
The ASCII or
Yeah, exactly. Anybody else?
So for your whole left and right side thing, like I say, like the special characters usually would be on the end of a password.
Possibly, or the beginning.
So for a password scheme, would you want to say put special characters in the middle? Would that get around what is your password profiling for the left and right?
Oh, you're just saying that password strength in general?
Yeah.
Yeah, I mean, again, length of password, it's almost like nothing's safe these days. And so unless you're using an encrypted way to store your passwords and you're randomly generating, 10 plus, 12 plus character passwords for every single thing you do, I mean, it's best to have special characters in the middle and the beginning, along with uppercase, lowercase, and at least a digit, or something like that. Because the more stuff like that you add, the more complex it's going to be.
Even if that's less than 12 characters, you're still not safe because you get so many.
I mean, right now, and again, it's not like everybody in the world is extremely hip on password cracking in general, but right now, I mean, if Martin and I wanted to get into any hashed anything that is below 12 characters, we could do it in less than 3 days. So, I mean, again, you'd have to really have the want. I mean, I've never had a reason that I really wanted to break into something that bad, or whatever. So I don't. It would have to be somebody who was malicious, and it would have to be somebody who knew what was going on with password cracking in general.
I mean, and your theory's good because putting special characters in the middle would get around a lot of the attacks that we would do off the from the beginning, where we would generally put them in the beginning and the end. Where that type of reasoning fails is if you do that personally, you'd probably be much more secure. But if you're a system admin at a company and you require everybody in your company to do that, that's where it's going to fail, because now you've created a pattern in the fingerprint attack. So all we need to do, say, is brute force, 50 or 60 passwords from your database, and we see that the fourth and fifth character every time is a special character. Then we can, modify our attack to based on that schematic, and then crack more passwords that way.
Yeah, and so for instance, lowercase and digits at 6 characters, we can probably crack every single combination of any style hash in like 3 seconds. So definitely, but when you add special characters to that, I mean, it doesn't add a lot, but it's infinitely bigger, right? And so if it's just 8 characters and you're using at least uppercase, special characters, lowercase, and digits, for instance, I mean, it can take more time. I mean, I think an 8 character at that for NTLM is like a day.
Yeah.
Seems to me like
7 hours.
You know what I mean?
Seems to me like passphrase is the way to go.
That's a great
It's a good way to go.
So people
But
put dictionaries of historical
there's
quotes and-
dictionaries of passphrases too. You know what I mean? I mean, there's
Movie
a
quotes
lot
and
of
historical
different stuff out there.
phrases.
Comes out to length.
Yeah, it's length.
Length and complexity.
Size does matter.
And nobody being able to size you up in any way, shape, or form, such as grabbing your word list
This is
from
all
your website.
predicated on getting.
Size does matter to the size of your password, but
True.
according to this
Absolutely.
tool, you can get by with a small dict. Just.
It is predicated. You're right on getting the hash, but I mean that's
I mean, if you manage a network with more
it's
than 2
trivial,
users,
and when a network
one
is
of them's
exploited,
right.
I can guarantee you that the first thing that happens is the hashes are dumped.
That's the idea.
And on top of that, most websites, have at least some kind of XSS or SQL injection vulnerability, and most of those websites are linked to the SQL database. And for example, like WordPress, if you don't change if you don't change the WP underscore of the WordPress database, then technically anyone who wants to SQL inject a WordPress database already knows the names of all your tables.
So, and also, say it was just a WordPress site and the site means nothing, but the employees have signed up for it. If you just get a password out of that, then you've got a password. They probably use the same password for their computer.
Yeah.
So you've got their password in their computer, and, if it's a 6-char password in like a minute. And so then the entire network's vulnerable.
And that's part of the whole point of this class is people use passwords all over we use passwords all over the place. So if you crack it in one place, you can try it on one of the other systems that might be hashing it in a much more secure fashion, but still get in because you've cracked it via a different method.
Exactly. Or they may add 1-2 to the end or something like that. His computer fell asleep.
Oh.
And so, yeah. Go ahead.
I was going to say that's kind of the point of the expander because, for example, I'll use, everybody knows that Dan Kaminsky got hacked recently, and that's because...
Well, about a year ago.
That's because every single one of his passwords was FUCK, whatever app it was. So, like, if it was MySQL, it was FUCK MySQL. If it was Outlook, it was FUCK Outlook. And if it was something else...
My VNC password was in honor of Dan Kaminsky.
So, that was his pattern, and that's how he remembered his passwords, and that's how, somebody figured out one, and he got hacked all over the place.
Ouch.
Sorry, Dan.
Wow.
You got some more questions?
If you're just doing like lowercase, like 2 lowercase on the left and 2 lowercase on the right, it's going to look for 4
Specifically,
lowercase passwords.
Every password in my hash file was 3 3-letter passwords.
you wouldn't get a single one. Exactly. So, and here's something weird with Hashcat is it's built for complex scenarios that are longer in length. And so doing, for instance, 2-character passwords only, it just doesn't. It'll crap out the IRQs on the GPU cards and all sorts of stuff. So because you can do that with CPUs so easily and so quickly, it's really built for more complex scenarios where they're longer, harder to get passwords, and using a GPU you can do so many more combinations per second.
So if somebody has a password standard for their organization, it almost makes it easier for Hashcat.
Absolutely.
Depending on what that standard is. And so that's the problem is a lot of security professionals will say, create a password with the first letter uppercase with 4 digits on the end or something. And if that is the type of policy, that's a big problem.
One place I worked, they actually told us not to guide people when they're creating passwords. Do this, but we pretty much have to because our rules look so complex that if we didn't tell them, they'd keep trying stuff, even though it wasn't in the policy rules, and they would keep screwing it up. And try to password.
For me, the best policy for that is to literally. The only way to combat this is random generated passwords that are a specific length and a specific character set. And when I say specific character sets, I really mean every character available. So it's. That's a really big problem in corporations because you could have the most complex password schema in the world, and 50% of the people that work at a normal corporation are going to tape it to the other side of their keyboard, and so
They'll normalize it somehow.
Yeah, exactly. And so that's the problem is keeping it up, changing it, all this stuff, because it's really just an odds game. If you have everybody change their password every 6 months, it minimizes, getting
it increases the number of people who actually write it down and put it on the screen.
But the truth of the matter is every corporation in the world has many flaws, and if somebody spends enough time, they're finding it, and anybody can get hacked at any time, basically, is my personal opinion, if it's plugged into the internet.
Exploits are temporary. Bad design decisions go forever.
We covered most everything, but I'm just going to finish the slides real quick. Let's see. So I'm just going to go through them real quick. So that was our brute force example. And like I said, I'll put these up somewhere so you can see them. So we did the brute force. This is the example of that hybrid attack like he did with the dictionary file on the left and 2 lowercase digits on the right. Or that's 2 of every single possible thing on the right. But those can be made numbers or whatever. Anyway, And then this is all about the fingerprinting attack, which we all talked about. Like I said, I'll put this up on Question Defense so anybody can reread it, but Alex explained the attack really well. There's a few tips and tricks that Adam gave us. The fingerprinting attack is designed to work with GPUs. If you're using CPUs, you just want to make rules. You can use your own word list. You don't necessarily have to extract the word list from the example that we did. We brute forced the word list and then started out with that word list so that we could look at patterns that that word list had. But you could also just as easily use your own word lists and see what you could get. Also, like I said earlier, you got to be really careful not to use huge word lists with the expander. It will get out of hand really quick. You can build your own pattern dictionary really easily. And then another thing to do is to limit the length of the patterns. I did not put it on here, but there's a variable that you can change. It'll be on the notes that go with this. There's a variable that you can change in the expander so that you can limit the length of the passwords that come out of it. So if your pattern dictionary, for example, had 8, 9, and 10 character passwords, you wouldn't want the expander to come out with 20 and 25 character passwords. These are my two absolute favorite places to get word lists. The first one is Ron's site, Skull Security. I think Adrienne already talked about that.
Go Ron.
But this site, I'll see if I still have internet.
He also does a lot of stuff with Nmap scripting engine, if I'm not mistaken.
He does all the SOB scripts.
Is that what it? Oh.
Let me see. Let me show you this. This guy has the biggest. This guy has the biggest compilation of word list links on the web so far. This guy's name is MK4. He was actually on our Hashcat team. Here, downloads word list. So this guy has, as you can see, has just about every word list on the internet listed here. And so these are all places you could get word lists. Yeah, that's an MK40 site. This is his blog. Anyway, so this guy's blog is really cool, Hashcracking. He's one of the guys that hangs out and works with Hashcat. But in any case, if you want word lists, this is the way to go. And he has Skull Security and all that stuff listed on there. And here's Skull Security Ron's site in case anyone wants to see it.
Oh, password.
Well, this is just the thing. But anyway, so
The Rocky one's the hottest one.
yeah, the Rocky one's the hottest one, wherever that is. But anyway, there's like the configure password list, which is somebody intercepted the configure worm one time and dumped all the passwords that it had collected while it was out worming around. And so those are also real life.
Well,
Sounds like a bad Friday night.
or a good Friday night, depending on your point of view.
So here's the list from Hack5 when they got hacked. So in any case, Ron's site is really good with real life passwords. He's pretty quick to put them up there.
Oh, no.
Anyway, so there's that. And then, so this is my shameless self-promotion. This password crap sucks. I hate doing it. You can let us do the work for you. So we have an online password cracking service at tools.questiondefense.com. We support these algorithms. So far, WPA is pretty much our biggest since it's the slowest and nobody wants to crack WPA and nobody can do it as fast as we can. We can return,
Literally nobody.
3 hours. Literally nobody can do 980 million words in 3 hours. I don't know if anybody's used to WPA cracking, but on a high-end gaming desktop, you might get 3,000 hashes per second. So we're about 50 times faster than that, or maybe 100 times. Anyway.
What was that website you were just at? They had the Hotmail and all the others up there?
Skull Security,
I
Skulls.
wiki download page, but I didn't see it.
I may have hot linked right to his thing. Anyway, it's if you go to Skull Security,
Uh-huh.
wiki, passwords. Here, let me see if I can get it from the main page so you can see it.
Or Google search
Well,
Skull
yeah, I'm
Security
on that
passwords.
page.
You're on which page?
I was on the page you were just on, I just didn't.
Oh,
Something
well-
like a white text, a white background.
Yeah, he has them individually listed here. So you can just download them one at a time. Oh, I guess I'm running out of batteries. So I guess the talk's over when you're running out of batteries. Anyway,
Oh, I see it. Okay.
oh,
Can you go through from where you have the password file already and registry file?
So what is that program in C++?
just C.
Just C? It's not C++?
I don't think so. I'm pretty sure it's just plain old C.
Hey, is there any doing it with practice hashes for you to the economy and play around?
Hashkiller.
Yeah, if you go to hashkiller.com, there's a tab that says open crack maybe, and then there's an area over on the right where you can download that. Every day they post about 400 or maybe 40,000, I don't know. But anyway, they post a whole lot of MD5 hashes every day, and what happens is people submit the hashes, and then it looks in their database, and if it can't find them, it adds them to a queue, and then every day you can download it, and then it's kind of a competition. People try to crack as many as they can and upload them as fast as possible, and then it will, if you're registered, it will give you a score next to your name. But it's fun to practice.
Yeah, I'll play around with it.
All right. Guys, I appreciate y'all coming, and I think you said y'all are going to end.
Yeah.
I appreciate it, and thanks for showing up, and you did a great job. I'll make sure it's okay. You got my program this in when I put it down. So your question fence down on the on the logo. And our next speaker has to go to the restroom, so everybody meet back here in about 5 minutes. Does that sound good? Yeah.